Welcome to the course on cloud computing. This is an introductory lecture which will tell us the motivation to study cloud computing. It will give us an overview of the course, and we'll also see what industry is saying about cloud computing these days. Cloud computing has grown exponentially in recent years. So we have a graph here, which is a revenue forecast graph, which is published by Gartner. Gartner is world's leading research and advisory company, which periodically takes out these forecasts on new and emerging technologies. So we can see here that the revenue, which is in billions of US dollar, is increasing and the trend continues upward. So the cloud computing growth has been phenomenal over the past few years and is, let us see some of the biggest players in cloud computing industry. We have Amazon, which offers Amazon Web Service, Microsoft Azure, Google Cloud, and many more. Worldwide cloud infrastructure service revenue in 2019 was 96 billion US dollars. Now, this is a huge motivation for us to study cloud computing because it shows that it is evolving and will continue to do so. To see how cloud computing has evolved and what is going to happen next, Gartner has a prediction mechanism which is called hype cycle. Hype cycle is a branded graphical depiction developed and used by Gartner to represent common patterns that arise with each new technology. So let us see this. Every new technology, when it comes at this point, which is called a technology trigger. It quickly climbs up the visibility till it reaches peak of inflated expectation. It is called inflated because the market expects more from this technology. Then it climbs down to the trough of disillusionment because people quickly forget about this new technology as they expected a lot from this, more than what it could offer. At this point, the technology can either vanish or it can climb up the slope of enlightenment. The technologies which climb up the slope of enlightenment are good technologies. And finally, it reaches plateau of productivity. So any technology which reaches plateau of productivity is then going to stay for a long time. So Gartner comes up with hype cycle every year. So let us see its prediction about cloud computing. So this is the hype cycle for cloud computing in 2011. And we see that cloud computing is here. It has already reached a peak of inflated its way down towards the trough of disillusionment. This is the hype cycle for cloud computing in 2018. We see that cloud computing here has reached slope of enlightenment. It will take some time to reach the plateau of productivity. So we are sure that cloud computing is a technology which is here to stay. Overview of cloud computing. It has 5 components: resources, which is server, network, service, and application. Second is essential characteristics, which is on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Third, deployment models, which are public, private, community, and hybrid cloud. We'll look at these in detail in coming few lectures. Next, delivery models. We have delivery models as software as a service, so platform as a service, and infrastructure as a service. XaaS. X stands for either software or platform or infrastructure. So the services which are offered by cloud are broadly classified into these three categories. Then infrastructure, which is distributed infrastructure, resource virtualization, and autonomous systems. Let us look at the resources. First, server. These servers are compute servers or storage servers. So these servers are actually located in data center. They're housed in a data center. Let us see what is a data center. So Cisco defines data center as, it says, at its simplest, a data center is a physical facility that organizations use to house their critical applications and data. A data center's design is based on a network of computing and storage resources that enable the delivery of shared application and data. So cloud providers, they acquire large number of servers, which are compute and storage servers, and put these together to create what is known as data center. So this is how a data center looks like from outside. This is the Facebook data center, and it is very big. It houses large number of servers. This is the inside view of a data center. So if it has large number of servers, tens of thousands of servers, which are arranged in these racks. All these racks and the servers within it are networked, and this network is called as intra data center network. Next resource is network. Now these huge data centers have to be networked properly so that users can be. Next resource is network. Now networking is a very important component, as these data centers it should be allowed to access them from outside by the users through a proper network. Next resource is service, which is provided remotely by a cloud provider. So that is, resources are gathered in form of servers and are deployed to the user. So services primarily are the applications. There are many more services which are deployed, but right now we are talking about applications. So if we develop an application and deploy that application, that is, we store in the data center, in these servers or storage, then they'll be made available to the user over the network. So basically these are the resources in cloud computing. So now let us see what cloud computing is before looking at various definitions which are existing for cloud computing. So simply putting, cloud computing is on-demand delivery of computing service over internet. These services include, but are not limited to, servers, storage, processing power, network, IT infrastructure, development platforms, and database. The term cloud has historically been used in telecommunication industry as an abstraction of the network in system diagrams. Cloud then became the symbol of the most popular computer network, the internet. Since cloud computing is an internet-centric way of computing, that is, the services are offered to the user over the network, that is why the name cloud computing is apt for this. Now let us look at the various definitions. The first definition has been given by National Institute of Standards and Technology, NIST. So it says that cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. Example: network, servers, storage, application, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. So ubiquitous means everywhere. So it enables a network access which is everywhere, convenient and on demand to a shared pool of resources. So these shared pool of resources have been created by cloud provider uh, that is that are housed in a data center, and they provide service that can be rapidly provisioned and released. Then Gartner defines cloud computing as a style of computing in which scalable and elastic IT-enabled capabilities are delivered as a service using internet technology. So the computing resources are scalable and elastic. That means they can increase or decrease as per demand, and they are delivered as a service over the network. Let us see a few other definitions before going forward. Boyer defines cloud computing as a type of parallel and distributed system consisting of collection of interconnected and virtualized computers that are dynamically provisioned and presented as one or more unified computing resources based on service level agreement established through negotiation between the service provider and consumer. So it says that it's a type of parallel and distributed system which consists of collection of interconnected and virtualized computers, that is nothing but your data centers, that can be dynamically provisioned, and it has to be done under some kind of service level agreement. Oracle defines cloud computing as renting instead of buying your IT. So rather than investing heavily in database software and equipment, companies are opting to access their compute power via internet and pay for it as they use it. So Oracle says that instead of buying the IT infrastructure, that it can be rented, and the billing model should be pay for it as per use. And these IT infrastructure or the services should be available via internet. So by looking at all these definitions, we can say that cloud computing is a system where resources of the data centers are shared among the users to provide them service which is elastic, which is on demand, which is instant, and the users are charged on pay per use go model. That is, they pay only for the amount of service and the time for which they have used that service. So let us see next that why users, firms or organizations should go in for cloud computing. We'll contrast the two methodologies in which one, the user sets up the IT infrastructure on the premises, and in the second one, they take the same services over the cloud. So if the users set up the IT infrastructure on premises, they'll have to buy the servers or data centers. Then they'll need the space to set up the IT infrastructure. This IT infrastructure will also have to be managed by the user. So they'll have to maintain the hardware, manage the hardware, and also the software, upgrading of the software. Everything has to be managed by the user. To do this, they might need to employ manpower. Then there is an upfront payment. Upfront payment is the capital expenditure involved in buying the IT infrastructure and the space to set it up. Then expanding this infrastructure, which is on premises, needs planning and will be costly and time consuming. Then it does not provide elasticity. That means that the amount of resources which has been bought, the number of servers which has been bought and installed by the user on the premises, they cannot be the resources cannot be increased or decreased as per the usage. uh, the user has already invested in certain amount of resources. Now, depending on the usage pattern, they can be either underutilized, or they might fall short of the resources. Lastly, the planning time is high. So if I plan to set up the IT infrastructure or data center on the premises, it will take long time to from the inception to the actual functioning data center on the premises. On the contrary, if the user goes in for services over the cloud, then there's huge saving in capex. Capex is capital expenditure. So in there's no need to buy the IT infrastructure. So there is a huge initial saving. Then the user, since they will not buy, they will take the resources from a data center which is an off-site data center. So no space is required on the premises which is to be acquired for setting up the infrastructure. Since these services are being offered by a cloud computing provider through his data center, the data center is maintained by the cloud provider. If little or if some management has to be done, then there is a console which is provided, which is a self-service interface console which is provided to the user, through which it can be done. The billing model is pay per use go, so there is no upfront payment involved. One very important thing is in cloud computing is that there is illusion of infinite resources. So whenever a user demands for resources, they are provided with that resource. So user has an illusion of infinite resource. Then it provides elasticity. By elasticity, we mean that resources grow and shrink to fulfill the demand of the user. During the peak hours, if the computing power and storage resources required are more, they can be obtained by the user, and when the demand is not there, they can be returned back, and the users will be charged only for the amount of resources they have used. Obtaining the resources is a matter of minutes. User can demand for these services, new services, and they will be instantly deployed. And unlike on premises, the demand for the service is catered to within minutes in cloud. So it does not take time. So if a user wants some new service, it can be obtained over cloud within few minutes. So let us see some basics of cloud computing. Cloud services are almost always delivered remotely from an off-site data center. So this data center has been set up by a cloud provider, and they offer these services to the users over the network. So what does this cloud consist of? It consists of physical machines in data center of the cloud provider. Cloud services are delivered by virtualization. So virtualization is an important technology which allows the cloud provider to share the same physical infrastructure among multiple users. So we'll see what is virtualization in detail in later lectures. From the user perspective, virtualized hardware is identical to local physical hardware. Software that performs virtualization is called as hypervisor, or it is also called as virtual machine monitor, VMM. Okay, next, cloud economics is favorable in general because it offers flexible charging plan, because we understand now it is a pay per use go model. Whenever the user will use the service and for the time duration, they are charged for the service only for the time duration they use it. Secondly, organization of every type and size can have access to a similar infrastructure. This is a very big advantage, which wouldn't have been possible otherwise. Next, users can manage cloud service through a console. We have already discussed that. It provides mobility. The users can bring up a virtual desktop on a mobile device. Then cloud computing gives 24/7 availability of the services and resources. They are tolerant to failures. There are also some challenges with cloud computing as the services are offered by a third party, and the data is under the control of the cloud provider. So users are definitely bothered about the security of the data, more so if the data is sensitive. We'll look into the security aspect in later lectures in this course. So let us see the 5 essential characteristics which have been defined by NIST. These essential characteristics are also known as defining attributes of cloud computing. The first one is on-demand self-service. By on-demand, we mean that the user need not inform or in advance to the cloud provider about the services required. And self-service is user can obtain or consume the services of the uh, cloud on its own without any intervention from the cloud provider. So let's see, so user can select the resources needed as per their requirement, and they can access these resources anytime from anywhere, because these services are offered from a remote data center over the network, so they can, so the it is location transparent. Then users can add or remove the services whenever they want as per their need. The service is accessible via a web browser or a web service API, that is application program interface. So is broad network access. The nature of cloud computing should support all standard protocols and devices, that is any network and on any web enabled device. So it says that the services which are being offered through cloud provider should be accessed over a wide range of network, standard network or heterogeneous networks, and they can be accessed through any web-enabled device, be it mobile, tablet, laptop, workstation, or any other new device which comes into the market. Third characteristic is resource pooling, which says that resources are shared among multiple users and are allocated dynamically in a multi-tenant environment. So this means that resources offered by the provider should be pooled together. That means the cloud provider should collect and pool these resources together. These resources being the storage, processing, power, network, bandwidth, and many more, so that user can easily access them. Then these services should be available to the users, any number of users and any time. That means it should be shared among multiple users. So that means the same physical infrastructure is being shared by multiple users, and this is called as a multi-tenant environment. So in resource pooling, it says that the service can be dynamically assigned and reassigned to a user on demand. Next essential characteristic is rapid elasticity, which is the ability to scale up or scale down resources whenever required. This we have already discussed. Finally, the last is measured service. It says that resource usage can be monitored, controlled, and reported providing transparency for both provider and consumer of the utilized service. So it means that the resources which are being used by the user should be measured using some metering capability. So whatever user is using should be measured. And it can be also monitored, and there should be transparency so that there is no point of confusion on how much resource has been used by the user and how much has been provided by the cloud computing provider. Actually, this concept of measured service comes from utility service like electricity, newspaper. So if as in electricity, the amount of electricity which we use is metered and we pay based on the consumption. So we say cloud computing is a kind of utility computing where the services which are provided by the cloud computing provider should be metered, measured so that users, and it should be transparent so that the user pay only for the resources they are using. Okay, so now let's see some use cases of cloud computing. So we understand that cloud will make the business agile. It will reduce the cost as it eliminates capital expenditure completely. Uh, the resources can instantly scale, and these services can be deployed globally in minutes. So, cloud computing has been widely adopted by various in various. So, cloud computing has been widely adopted. Let's see some examples. The first one is for healthcare companies. So, healthcare companies have adopted cloud computing to develop personalized treatments for their patients. So, history and the record of the patient can be stored in the cloud, and this can streamline the admission and the care and the discharge process in a hospital. Then the patient can also access their own health information from all the care providers and store it in a personal health record. Um, so, cloud computing can also provide a personalized health record for the entire family. So, patients can then access their own health record, even the hospitals, and they can securely access the patient's data stored in the cloud, and also share this data with other hospitals and physicians if required. So it simplifies the overall process of healthcare industry. Next is video game makers. Video game makers all across the world have been developing the games on the platforms provided by cloud providers, and launching the games to make it available to millions of users over the net. Next is education. So cloud computing has really improved the quality of online education. Um, so applications, cloud collaborative applications like online forum help students to discuss common problems and seek guidance from the experts. Users Universities, colleges, schools can also use cloud-based information management system for admission process, improving administration, offer distance education, and for online exams, and for many other instances. So basically, the cloud-based online learning systems do provide high quality education materials to student, and so cloud computing has really revolutionized our education system. Okay, next is cloud computing for government. So cloud-based e-governance system can improve the delivery of services to the citizen. Public services like vehicle registration, issuing of driving license, income tax filing, paying of electricity and water bills, birth certificates, etc. So they can be facilitated through cloud-based application, and the benefit of using cloud for such public service is that the application can be scaled up to serve a very, very large number of citizens. So cloud plays a very important role in not only these but many industries, hospitality industry, production, financial industries, and many, many more. To sum up, in this lecture, we saw that how cloud computing has evolved and is still evolving, and its growth has been phenomenal and is expected to continue that way for coming years. We saw the various definitions of cloud computing which are existing in literature. We also saw 5 essential characteristics given by NIST and some use cases. These are the references. Thank you.